Section 1.5, Exploring Angle Pairs. Adjacent angles are two coplanar angles with a common side, a common vertex, and no common interior points. So basically they share a common ray. So let's assume we have our vertex here. We have this middle ray, but then we have another ray here, making one angle, and then the other angle has to share that common middle ray. So we've created two angles using a single, or sharing a common ray and a common vertex. Vertical angles are two angles whose sides are opposite rays, or straight angles. Vertical angles are congruent. So the easiest way to think about this is if you draw an X, like that, your vertical angles are the angles opposite one another on basically the inside of the X parts. So those two angles should be congruent, as are these two angles here. And keep in mind the arcs here indicate congruent. Single arc to single arc means those angles are congruent. Double arc to double arc means those angles are congruent. Complementary angles are any two angles who, when added together, have a sum of 90 degrees. Each angle is called the complement of the other. So if we have an angle here, let's say this is 42 degrees, then our other angle has to be 48 degrees. Complementary angles don't necessarily have to be adjacent. They can be separated, but they could also be adjacent as well. Supplementary angles are two angles whose measures have a sum of 180, and each is said to be a supplement of the other, or a supplement to the other. So let's say we have one angle here. This one, let's say it's 130, and then the other angle is 50 degrees. So those two together add up to 180, so they are supplementary angles. All right, so we're just going to name some examples here. So an example of adjacent angles, well, I'm going to go ahead and use 3 and 4. They share this common side here, or common ray. So let's say 3 and 4. There are other examples, but just for now I'm going to use those two. Vertical angles, well, we're thinking about our two straight angles, and then we're taking angles on opposite sides. So I'm going to say 4 and 1. Complementary angles mean they have to add up to 90. Well, this symbol means right angle, which means 90, and it's built from 3 and 4. So I know that 3 plus angle 4 add up to be 90 degrees. So that must be our complementary angle pair. And then supplementary, well, to be 180, they would essentially create a straight angle if they were put together. Well, if we look carefully here, 5 and 1 do exactly that. So 5 and 1 are our supplementary angles. So name an angle or angles in the diagram described by each of the following. Here we're looking for an angle that is complementary to BOC. BOC is here. If this is a 90-degree angle here, then we can assume there's probably going to be one here too because of this straight angle. So that means the complementary angle to BOC must be angle AOB. And then this question asks, if BOC is 47, what is the measure of its complement? So basically, what do we have to add to 47 to make 90? Well, 43. Then they want to know a supplementary angle to DOB. Well, DOB is this obtuse angle here. To be supplementary to DOB, we should probably find an angle that helps make a straight angle with DOB. Well, BOA works out, so we're going to say angle BOA, or AOB. And if DOB is 127, what is the measure of its supplement? So what has to be added to 127 to make 180? 53 degrees. Last but not least, we're looking for an angle that is adjacent and supplementary to AOC. Well, adjacent to AOC, so AOC is here, and supplementary means we need to find another angle when added to AOC basically makes a straight angle in this case. Well, that would be angle COD. When finding info from a diagram, things you can assume or conclude from unmarked diagrams include that angles are adjacent, because you can see that in the picture. They're adjacent and supplementary, because you can tell if they're touching and if they make a straight angle. And that angles are vertical angles. So that you can pick out because you can see the intersection of the two straight angles, and that one's pretty straightforward. Things you cannot assume or conclude from the unmarked diagrams include that you cannot assume just from a picture that two angles or segments are congruent just because they look the same. You also cannot assume that an angle is a right angle unless it has that symbol in the right corner, the little square, or it's beside or adjacent to one that is. You can also not assume that angles are complementary unless you know that, once again, like you have that right angle symbol. That's the only exception. All right, postulate 1.9, the linear pair postulate. And we've actually looked at a bunch of these so far in this lesson, so we're just going to give a term to it. If two angles form a linear pair, then they are supplementary and adjacent. So previously in the notes, we were looking at a lot of angles and trying to find their supplements, and we always seemed to find the ones that were adjacent to it and made the straight angle. Well, that's what a linear pair is. They're two angles that are adjacent to one another, and they make a straight angle. So they're supplementary and adjacent. So we're just giving a proper name to it, and that name is linear pair. So anytime you see linear pair, know that the two angles add up to 180 and that they are also adjacent to one another. An angle bisector is a ray that divides an angle into two congruent angles. So like a segment bisector, you're just cutting something in half, but this time they're talking about an angle. And so in this case, this ray is cutting ABC into two congruent angles, so that AB, and let's say D here, is congruent to angle DBC. So angle bisector creates two congruent angles. If the measure of angle PQS is 53, what is the measure of angle PQR? All right, and they tell us that ray QS bisects PQR. So we need to draw the diagram just quickly. So we'll go ahead and say, I can do better than that. So we've got PQR, and then we know that QS bisects it. So S is here. And we're not really drawing this to scale. We're just kind of getting the feel for it. So PQS is 53. That means that SQR must also be 53 because QS is the bisector creating two congruent angles. And so if that's the case, we're just going to take 53 plus 53, which in this case equals 106. So the measure of angle PQR is 106. All right, this time, ray QS bisects PQR again, so we can sketch the situation again. We'll just draw a nondescript angle. So S, P, Q, R. We know that the two angles are congruent. All right, they tell us that PQS is 3x. They tell us that SQR is 5x minus 20. And they want us to find the measure of PQR. Well, to do that, we should recognize that the two angles are congruent because of the term bisect. It cut the angle into two equal parts, plus we know it from our diagram. So we're going to set the two equal to one another, because I know that the measure of PQS equals the measure of angle SQR. So that's 3x equals 5x minus 20. Then I'm just going to solve. So I'm going to subtract 2x, or subtract out 2x. I'm going to subtract 5x from both sides. There we go. I get negative 2x equals negative 20. I'll divide by negative 2, and I should get x to be 10. Well, to find the measure of PQR, I just need to plug the 10 back into both of the angles I already know. All right, so in this case, PQS is 3 times 10, which is 30. And the measure of angle SQR is 5 times 10, which is 50, minus 20, which is 30 as well. So that means the measure of angle PQR equals 60. Once again, ray QS bisects PQR. All right, so we'll sketch the situation this time. Again, so QS is in the middle. This time PQR, they give us the entire angle itself, which is 3x minus 12. And they tell us that PQS is 30. Well, if QS bisects the angle, that means that PQS is 30, but it also means that SQR is also 30. So what we have to recognize here is that the measure of angle PQR, or the entire angle, is equal to the measure of angle PQS plus the measure of angle SQR. So if we set up and we plug in what we know, we've got 3x minus 12 equals 30 plus 30, because they're congruent angles. So now we've got 3x minus 12 equals 60, and we're just going to solve this. So I'm going to add 12 over. I've got 3x equals 72. Then I divide by 3, and I get x to equal 24. And then to find out what PQR equals, I can either plug the x back in to make sure it works out, or I can just recognize that I already know that it should add up to be 60. So PQR is just 60. All right, last but not least, we're talking about angles 1 and 2 form a linear pair. So that tells us right off the bat that these two add up to be 180 degrees. If angle 1 is 6x plus 15, and angle 2 is 2x minus 10, find the measures of angles 1 and 2. Well, I just have to set this up accordingly, because I know 1 and 2, so angle 1 plus angle 2 should equal 180 degrees. So I'm going to plug in the equations accordingly. So 6x plus 15 plus 2x minus 10 equals 180. I want to combine like terms, so I've got 8x plus 5 equals 180. I'll subtract 5 from both sides. I get 8x equals 175. And then I'm going to divide by 8. And in this case, I get x to equal a decimal, which is unusual, but it's possible. And so x equals 21.875. So to find the measures of angles 1 and 2, I'm just going to plug the x value back into each of their respective expressions. And so for angle 1, when I plug it back in, I should get that angle 1 is 146.25 degrees, and the measure of angle 2 is 33.75 degrees. And when I add the two together, I get 180, so I know that I've pretty much done the work correctly.